Let's talk about linear functions and whether or not they are increasing, decreasing, or constant. Specifically, our objective, determine whether a linear function is increasing, decreasing, or constant. Okay, so what do we know? We know what a linear function is. A linear function is a function of the form f of x equals mx plus b. Okay, the graph of a linear function is a line. The slope is m, the y-intercept is b, and the domain of a linear function is all real numbers, everything from negative infinity to positive infinity, using set notation, all x's, such that x is a subset of the real numbers. Okay, I'll just directly speak to this because it's gonna be very familiar to you and your work with lines. Okay, so when is a linear function increasing, decreasing, or constant? A linear function, again, f of x equals mx plus b. Well, it's increasing over its domain if its slope, which is the m right here, if its slope is positive. If the slope is going up from left to right, it is an increasing linear function. A linear function is decreasing over its domain if its slope is negative. So the slope is going down from left to right, again, just like a line, because it's a linear function, it's a line, we have a decreasing function. And if the line is flat, okay, we have a constant function. So it's constant over its domain if the slope is 0. We have a flat line, okay? So a linear function is constant over its domain with a slope of 0. This should all look super familiar because it's exactly what you would expect after all the work you've done with lines beforehand. Positive slope, the line is increasing. So a positive slope, the linear function is increasing. A negative slope means your line is decreasing. A negative slope means your function is decreasing. Your linear function is decreasing. And a slope of 0 means you have a flat line. So a slope of 0 means your linear function is constant. Let's take a look quickly at 3 examples. Determine whether the following linear functions are increasing, decreasing, or constant. Example 1, f of x equals 3/4 of x minus 4. Okay, well, m equals 3/4, which is greater than 0. Okay, so this function is increasing. Therefore, by the way, is 3 dots. You can say that the word therefore in math is 3 dots. Therefore, f of x is increasing over its domain. And I'll write this down with interval. On the interval, I'll kind of write this a little differently. On the interval from negative infinity to positive infinity. So you see me, I'm trying to write the notation for intervals, for set notation. I'm trying to kind of mix and match a little bit to keep all used to all these different things. So it's increasing on its domain. Its domain goes from negative infinity to positive infinity. Okay, example 2. G of x equals negative 2x plus 8. Well, the slope is equal to negative 2. Negative 2 is less than 0. So it's negative. Negative 2 is negative. Go figure. Therefore, g of x, the function, is decreasing. And this time I'll write on its domain. So another way of writing the same thing as I wrote up here. On the interval on its domain, which we know it's linear, so its domain is from negative infinity to infinity. Last example, h of z equals 7. Well, I can rewrite this. H of z is equal to 0 times z plus 7. Now it's written as a linear function. So the slope equals 0. Therefore, the function h of 0 is constant. It's a flat line at 7. Is constant on the interval negative infinity to infinity. Again, just a variety of ways of writing things. There you have it. Okay, so we have just like you know about with lines. If the slope is positive, it's increasing over its domain. If the slope is negative, it's decreasing over its domain. If the slope is 0, it's constant on its domain.